Well, hi, good morning, and thank you for joining me in my shop. Today is January 19th, and it's a cold day here. It's minus 10 outside, but windy, so it feels much colder. And it promises to be cold for another day or two. And then I think a warm-up is coming. So, now the last thing I did with this radio was a IF alignment. I'm not sure I got it really all that good. It certainly seemed to be out a long ways. And so I think what I did yesterday, or the last time I was in here, which was yesterday, I think I got it improved, but I don't by any means think it's 100% or where it needs to be. This is just the IF alignment. I think there were 3 transformers I worked on there. So what's next in the process requires this capacitor, the 10 microfarad 25 volt capacitor that was sitting about here, to be replaced or reinstalled. I'm not going to reinstall this. I had confusing tests when I tested this out of the radio. I don't know what to make of it. So anyway, I put a new one in right here, and because it has to be in and connected for the next test, I've gone ahead and tack soldered it here, but my expectations are I'll be lifting it off at some point in the future and redoing all these alignment tasks. What I find anyway, the first time I go through a radio like this trying to do the alignment, I pretty much make every mistake in the book if I can do it. And then by the end of that process, I know what I'm doing. I start it over and do it again. So in other words, the first time through, I don't have any expectations of fantastic success. Success for me is just knowing the lay of the land and understanding the challenges with this particular radio, the information that's available, and all that kind of stuff. So if you think you're about to witness some kind of perfect alignment, no. No. Well, you might. It's possible. But I kind of doubt it. So the next step here is to take a look at the manual, the service manual, and read about the next step and see what it's all about. Let's do that. So what I've done is I've done these 3 tests. Oh, look at that. It says right there, disconnect the capacitor. So I'm about to do this one, and I was thinking the capacitor had to be reconnected, but it does not. No problem. I just tacked it on. I can disconnect it easily. And then we're putting the signal through V9. That's the last tube in the IF string. Sweep and marker generator 10.7. To audio output jack. That's the scope. The scope is connected to the audio output jack. And then we're going to try to see this kind of shape. I've always found this very challenging to get this to come out of a radio like this. Top slug of T8. We did the bottom slug here. Top slug of the straightest center portion of curve and balanced plus and minus swing. So they want this to be about the same amplitude as this, and they want this to be as straight as possible, not vertical, but as straight as possible, because the and I may be wrong in this, but the process of detecting the audio in the radio signal utilizes this straight portion of this curve, and if it's not straight in here, then you're going to get a distorted output. So I think that's what's going on here. 10.7. Okay. Okay, no problem. Drink a little coffee and we'll do this. Okay, I think I'm all set. Oop. Here come the bro. That's my cats, the two new cats I have. Okay, let's just go over what's happening here. The set is not turned on yet. I have the signal generator here running at 10.7. You can see 10.7 on it. That's fed into, it's going to be, on the end of it, it's going to be fed into V9. We're going to look at the result that comes out of the audio output. So I have a connection made there, where, here. Yeah, this is the audio output. Here's my scope connection to it. And you can see the display on the screen already from the scope here. This is being caused by the transformer here, which is producing the wobble effect. And I think we're ready to go. I don't know what else else I should do here. So are we going to get this nice S-curve on there? I wouldn't bet on it. I would not bet on it. Okay, here we go. We'll see what happens here. As I mentioned in my earlier videos, doing an FM alignment for me is quite challenging. I haven't done that many, and of course every time you face a radio the situation's a little bit different. So it does take quite a lot of experience to really get a grip on this stuff. That's what I find. And I've been using just the regular RF output from my signal generator back here. There is another output, a composite output, which I think I can probably utilize in the alignment of this radio, but the instructions that come, the Heathkit instructions themselves, of course, don't make any mention of that. So consequently, I'm following a procedure here which really isn't written in the book exactly the way I'm doing it, because I'm feeding in the RF signal at 100 megahertz into the antenna here. That's what this is down here. And so that's not really what they're saying I should be doing. Okay, so this thing must be warmed up by now. We have nothing showing up on the display at all. So I'm going to put the signal in from here. I would think we should have something on the display. Whoops, first I'm going to put the power up full. So we're dealing with. Let me just brighten this up a little bit. Yeah, nothing at all. Maybe it's just too insensitive. Oh, look. There it is. There's the guy right there. It's a little puny. Is it going to get bigger when I... So first of all, let me adjust the tuning of the FM transmitter, the 100 megahertz tuning. Let me just move it around a bit. Okay. Very good. Why so weak? Why is this so weak and so small? Let me crank this up. Okay, so I raised the output of the signal generator. So if this is an S-curve, the whole thing is above the line, when this back half should be down below the line. Let me tune the transmitter again and see if it changes shape, or it just changed position. It just changes position. So the shape is way off, according to this test. So I'm going to put in the marker generator now. 10.7 into here. We'll see what happens. This might just kill everything. Yeah, wow. That's a pretty small display to work on. Can I get? No, that's maximum sensitivity. Now I'm using a times 10 probe that's stuck on the times 10. And you can't switch it off. If I had a times 1, I'd have. Yeah, I'm going to change probes. I think that's one thing. But now, as for the marker generator, which has almost no output right now, let me raise it up. Okay, so the output should be pretty good. I don't see any indication. This is so small to look at. I'll swing the generator frequency a little bit, and we'll just see what happens. Let me give you a full screen view of this, because it's all about what's on here anyway. Small as it is, do we see anything? So I'm going to put the marker generator full steam. Okay, so we can see, we can definitely see something happening now. So, but it's not at all what I would expect. So you can't see the frequency, so I'll call it out. Because this is 10.65. This is 10.7. This is 10.75. This is 10.8. 10.85 actually. 10.9. What's going on? You can see a little blip on the right hand side there. So that is really marking the frequency at that point on the screen. And that would be 10.57. Let me just move it. It gets hard to see. I think, although it's bent the line funny and things are happening, I don't know what to make of it. That's probably the center of something. 10.76. Wow, this isn't working out very well at all. I got no more juice to supply in terms of the RF signal. I can't boost it that way. I'll change the scope lead here. I think it's probably the best thing to do. Do that. Now we could also listen to this. Oh, ooh, it's not up to 60. I don't have headphones on, so I don't know what you're hearing when I'm in here. I very occasionally put on headphones. Just stay focused here and do what you're doing. Just a second here. I'm all tangled up in my cords. When I was a kid, my mom would say to me, "Jim, when are you going to get rid of all those wires?" I didn't have the heart to tell her. I'm never getting rid of the wires, Mom. There's going to be more forever. So, oh, I had to pop that capacitor off. I didn't do that. Oh, okay, let's do that. So, cut the power. Soldering iron's still hot. Some pliers here. I forgot totally about this. Okay, so the capacitor is disconnected. Next time we do the test, well, maybe we should check it out right now. Okay, let's do that. Put on the power. Did I must have turned something down here along the lines, did I? I took the capacitor off and everything's disappeared. Oh, right, I was changing the lead, the scope lead, and I didn't finish. So this is another scope lead. It's also got a 1:10 ratio on it, but it's got a switch, so I can switch that off. ×1. And then we want to be just a little less sensitive. Then we're going to put this on the audio output, right? FM audio output. Okay, it's there. See what we get now. Oh, that's a lot better. That is a lot better. Now, remember, this is not a blanked sweep, so the sweep goes out and comes back, goes out and comes back. So it goes out, it'll describe one line, and on the way back it may describe a slightly different one. And that's why you see two images there. Okay, this is a little bit better. Let me put it on full screen for you. What I'll try to do here is, again, move the marker generator and see if it's clear where it is. It's at 10.76 right now. So we'll take it down. Oh, that's... Okay, so it's right here now. It's right where my finger's showing it. So I'm going to take it back. And we're going to go down. We're at the bottom now. Quite clear. We're coming up the other side, it's not so clear. The whole thing stretched out and did something. Wait, it just jumped to the left? Did it just jump to the left? Did it jump to the right? Okay. So, what would that be? That would be 10 on my frequency counter, 10.788. So if I actually move it to 10.7, can we spot it? So I mean, it's getting all shaky out here and everywhere. So that's 10.7 there, but I couldn't tell you where it is on here. It's everywhere. Yeah, there's some strange stuff going on here. I'll read through it. So this is 10, and then I'm going to go right up to 11. I'm just going to whip right through it here. Kind of see it come in this side, and then it gets down to here, and then everything changes after that. All probably just artifacts of bad alignment. .753. That's what I think this center part of this slope is. Okay, well, we got to get this into an S-curve somehow. So why don't we try what it says? It says just slug. Wasn't it? It was the top. Was the top slug? I better not guess at this. I'm going to take a look here. Just see what we've got. Top slug of T8 for straightest center portion of curve and balanced plus and minus swing. So that's exactly what we're having trouble with. The swing is not balanced at all. So, okay, top slug of T8. Now I have to locate T8 with certainty. T8, okay, I have done that. I'm looking at the book in case you're wondering what I'm doing. This is T8. Okay, I'm feeling the bottom slug going through. Okay, free zone. I'm in the top slug. Here we go. Oh yeah, look at that. Now, let me move the marker frequency around a bit. So you see it at the bottom there. Now it's probably halfway up. I'll tell you it's 10.7 on my machine. And then we go up higher, and now it's at the top. 10.75. Let's go right to the bottom again. Yeah, it's the bottom. 10.6. So, you know, it's pretty rough what I'm doing here. It's really quite rough. So again, trying to find the middle area. Let's see, that's the bottom. That's the top. That would be about the middle. 10.680 on my machine. Now, as I mentioned, I think in the video yesterday, somewhere I've got a piece of equipment with a 10.7 crystal controlled output. Where is that piece of equipment? I don't know. Okay, so I'm going to stop for a little bit. We got the right stuff on the screen now. I'm just going to take a little break here, and then we'll attempt to actually do this, make this correct somehow. I don't know how, but we will. Okay, it kind of struck me that we can actually listen to this and hear what it sounds like. So I'm putting my headphones on, and I'm going to turn the volume up. Don't know what we're going to hear. Probably just a big whir. That's what we're going to hear. Okay, let me fiddle with this a little bit. We'll watch and listen. In fact, let me switch this here. Okay, so that's me adjusting the upper slug in T8. Now I'm going to adjust the marker generator. See what happens here. Okay, so that's 10.2. Pretty clear. I can see this pretty clearly now. That's the spot where the marker generator is right in the middle, and that's 10.68. Wow, that's really close to 10.7. Probably what's happening here is I've aligned the IF to 10.7 or so, I believe. Let me turn this down here. And now, if I feed a signal centered on 10.7, it produces a balanced display that you see here. And so it should not be surprising that I got this pretty close already. We need to put an antenna on this and have a listen. I think that's what we need to do. So let's do that here. So I'm going to take the signal generator off. Wait, the volume's right down to nothing. Yeah. So this is the sweep generator coming off, and we're going to put this fantastic FM antenna here that I have. We're going to hook it up to one of the FM lines, and then I'm going to hang this, don't pop out, off my microphone here. So you might hear this a little bit, maybe not. In the background you can probably hear a ham radio going in another room. I left the volume up, unfortunately, and guys are yapping on it. Okay, so that's what we got there. Let me put the headphones on. Turn up the volume. Okay, sounds like an FM radio. Now, let's see if we can tune something in here. So I can't stay on any music any length of time, just a few seconds. So unfortunately, and that's by far the best way to judge these things.
Including late civil rights leader Marcus Garvey, who was charged with in the United States in 1923 and deported to his native Jamaica. Biden also pardoned immigrant rights activist Ravi Ragbeer and criminal justice reform advocate Albert Smith. Proud of you.
Sounds distorted to me.
And that is your world this hour. For CBC News, I'm Claude Fake.
Weather's coming next.
The weather forecast for the Barrie region, expect flurries this morning and potentially through the early afternoon. The wind chill -20 this morning and -15 this afternoon. A couple centimeters of snow expected tonight as the wind chill drops to -26 overnight. And in Peterborough and the Kawarthas, be prepared for cold conditions today. It's going to be cloudy with a...
Okay, so what are we finding out here? When I had the music tuned in, it sounded pretty clear, but this guy's voice is definitely got distortion in it. Let's hear it again. Hello.
I'm a reluctant anti-coal mine activist. I don't enjoy this process one bit.
Okay, but why are you wearing it then?
Because I drink the water.
Now, this is Corb Lund talking to me. He's a Juno Award-winning country music artist. His family has been ranching in southern Alberta for 6 generations. Corb is a household name in many parts of...
Sounds nice, a little quiet. So as I tune through, I'm looking for the 3 peaks, right? Let's go back up. I got a poor antenna on here. It does seem to be a sweet spot. You get a tune there. Some kind of interference noise. There's a strong religious station up around 100. That's my signal generator still doing its thing. Wow. Holy smokes. That were broad. I don't even have it hooked up. It's just broadcasting. Okay. Go on. I think it wiped out the religious station. I think it's right in the same spot. Now, it's a little tough to pick up FM stations clearly up in this area, and I've got a lousy antenna again. Sounds pretty good. How come that voice didn't sound good?
Peter Lougheed was the Premier of Alberta at the time. He restricted coal mining on the eastern slopes. And he went even further in an environmentally sensitive area near the BC-Alberta border by more or less banning mining there.
Coal has a much more serious environmental problems. It destroys most of its located in some of the beautiful parts of our province and would affect, for example, our potential for recreation and tourism. So there's limitations on how much coal we can produce. If it's on the plains, it can affect agricultural areas.
Okay, let's fast forward to 2020. The provincial government then headed...
I got my hand on the volume control here, so it went up quite a bit.
That coal mining in those
come on,
sensitive areas was back on the table.
This off.
Now we're talking about metallurgical coal. It's also called coking coal. It's not meant to be burnt here in Canada for energy. It's actually mostly used to make steel. And the Group Steel Watch estimates that process contributes to 7% of the world's greenhouse gas emissions. Although the broader climate impacts aren't the concern for many of the people who have added their voices to the public outcry, including Corb Lund.
I started talking about it, and Albertans, it wasn't just because of me, but Albertans, when they found out about it, were enraged, and there was more public outcry.
So when I'm listening to this, I'm listening to the bass, and I'm listening most importantly to the treble. And the best way to hear the treble is in the S sounds in people's speech when they talk. That's very high frequency stuff. So some radios, you can't hear that at all. Still know what they're saying, but here, let's listen again.
The ban on coal mining, and then in 2020 the government tries to reopen it. Albertans say no way, and the government shuts it down. Any more talk of it? Many Albertans thought it was a done deal at last, case closed, right? Well, apparently not. Here is Alberta's current energy minister, Brian Jean, just a few weeks ago announcing the plan to once again explore coal mining in the Rockies.
Today, I'm here to share my ministry's plans for the long overdue modernization of Alberta's coal policy with the launch of the Coal Industry Modernization Initiative. We're bringing coal development in Alberta from the 19th century to the 21st century.
Now, I want to ask you, Corb, what does it feel like you hearing Alberta Minister Brian Jean make that statement in late December?
I could say a lot about that. Number one, I don't think he understands the issue at all. I don't think he's very competent in his job when it comes to the coal issue. I saw that whole press
That's pretty harsh. Okay, so that sounded great to me. Look, I think it sounds good. Now, what should I do next? Good question. Turn the sound off and we'll look at what's next on the alignment chart. Let's take a look at this together. So I've just finished this step right here using the audio jack to get this curve, and seems to me we got it okay. Sounds okay. So this is what's left, these next two steps. Reconnect the capacitor, tune the dial pointer to 98. To the antenna input, and make sure it's not 50 ohms. That's what they're saying here. Stick a resistor in series with your, but I don't have to worry about that. I'm using a generator that's built for this purpose. Sweep generator 98 can't do that. I can do 100. Marker generator 10.7. Pin 1 of V9 through a 100K resistor, ground lead to V9 center post. Through a big resistor. So this is usually intended to increase the output impedance of the device, or the input or output impedance of the device you're connecting. So they're raising it up 100,000 K, and you know the values here don't matter. It's more the shape. So as long as it's good enough to get on your oscilloscope screen, that's good enough. So that's what's going on here, I think. Now look at this next one. Tune the pointer to 106. That's the top of the dial. 98's around the middle. 106 is near the top, isn't it? Sweep generator, marker generator. Adjust C39 located on top of pre-wired front end. Where? On top of pre-wired. This one here too. T5 located pre-wired front end. So that's probably the FM tuning box is what I would call it. When this kit was put together, a number of things came pre-tuned, and so you should just be able to put the kit together and everything is tuned right, and you wouldn't have to do these kinds of things. That's the idea. But here we are way down the road, and obviously this stuff needs to be done. So go through it again. We'll hook up the lead. We'll run the my generator at 100. I don't have any choice. The marker generator at 10.7. Where this is going into the antenna. So this marker generator thing. This is the problem here. They're thinking of a signal generator with a marker built into it, and I've got two different signal generators going here, and there is no 10.7 marker in the signal generator, in the FM signal generator. So if I'm going to introduce that, I can't just stick it on the antenna. That's not going to work. I got to stick it into the radio, into the IF, in fact, and that's not following this process at all now. So how do you do this? Is it even critical? What if we forget the 10.7? So we forget the 10.7. We'll get this kind of shape, but we won't know if it's really centered on 10.7 or not. Doing it this way, if we're doing it without the marker. So we could fool around with these slugs and change the shape, but we wouldn't really know if we're pushing it off this way or that. And as I said before, my signal generator is designed for doing this kind of work. So there's a way different than what they're suggesting here. And interestingly enough, if I hook up this C60, does the volume go up and get a lot better yet? We should listen to that. So I got everything operating here. Why don't we do that first? We're just going to, touch connect this capacitor, and we'll just see what kind of difference it makes in the sound quality and whatnot, because the radio's operating without it right now completely. Okay, let's try that. Okie dokie. So, where am I tuned now? I got to tune. Let's tune to the talk station there. Still talking. Uh-oh.
Save me from this space.
Really? That's kind of weird. Get by that one quickly. Come on, somebody talking. Sounds good. Really
I'm
good.
convinced that most of the people I work with on this are convinced that Grassy Mountain is the thin end of the wedge. And once they get that one in place, it'll be another one and another one and another one, and pretty soon we'll be like the Elk Valley of BC, which Albertans don't want.
Sorry there.
I want to pause here for a second to explain what Corb's referring to there. The Elk Valley in the Rocky Mountains is just across the border from Alberta in British Columbia,
Quieter.
where the BC government has allowed metallurgical coal mining to thrive for decades. Leftover waste rock from the mines piles up in nearby valleys, and a mineral called selenium seeps out of the rock into nearby waterways. In high levels, selenium is toxic to humans, and even low levels have been linked to deformities in fish. Selenium levels of more than 30 times the recommended safe levels for fish have been detected downstream from Elk mines. It's also freely applied into private wells on farms, and even municipal water supplies. That's despite the mining companies spending billions on attempts to crack contamination.
So it tuned to this side and that side of the station. I get a different response when I put the capacitor in.
Selenium remains in watersheds for decades.
Don't know what that means. That means, well, I do. It means things aren't balanced yet. We haven't got it 100% balanced. I think that's how I would interpret that. Okay, sorry, I should be hot. Again, I'm just going to tack this on. Come on. Okay. Capacitor's connected. Radio's on. Did I have it on full last time? Full voltage? Maybe I didn't. I do now.
It's very difficult to bring people together.
There's an output level control here. I'm going to adjust.
on this one thing.
It's a minimum.
And reiterate over and over and over that this isn't about the political parties, for me at least. This is about fixing coal mines in the Rockies. And it's very difficult to tease out individual issues because in this day and age, the left has a slate of beliefs and the right has a slate of beliefs. And it's like almost like you're not allowed to pick and choose. You got to pick one slate or the other, and that doesn't work for me. I'm very all over the place depending on the issue. But what my message to people is that to the left, I would say, if you care about the coal issue, you have to, for at least a minute, put aside your differences with your conservative brothers and sisters and come together on this one issue and focus on it and don't be prejudiced against their other beliefs. And to my conservative people, I would say that because it was the Conservative Party that caused this problem, I say to them, I don't care who you vote for. I'm not trying to tell you who to vote for. This is democracy. I don't care. But it's okay to tell your own side when they've made a mistake on a particular issue. And the UCP has made a mistake on this particular issue.
But when you think about the 5 generations that you mentioned who come before you...
What you're hearing here is kind of an example of the deeper political issues that exist in Canada. It's a big country. We're spread over a large area. The situation's different. Life is different here, there, and all through the country. And there's different concerns and the like, and this causes some conflict between people or differences of opinions. And then, of course, when it comes to leadership, which way should we go? That becomes the issue then, and the like. So, anyway, that's what you're hearing. Some of the deeper concerns here in Canada. I think every country has these kinds of things, these internal concerns going on, and hopefully the political system can resolve them in some way. Okay, enough of that.
Land stewards out there, and the First Nations people were doing it for thousands of years before that. But I feel great kinship with my ancestors, and I'm 1,000% sure that they would be on the same side as me on this thing.
Have you ever sensed that you would pay a price in your life as an artist for the stand that you're taking?
I wondered at the beginning, but...
Let's go hear some music briefly. A wide area now that's working good. It's not so sharp. That's probably the effect of the capacitor. I'm not sure.
Out of the room, and this is what it sounds like. 5, 4, 3, 2,
1. What happened to 1?
Can you hear the alarm? Hey Siri, shut my alarm off.
I've turned off your alarms.
Boom, done. I need advice, I need help.
What the heck is going on there? Just a small aside. At night, I like to listen to AM radio. Here in North America, there's 10,000 AM radio stations. Most of them very low power. But at night, you can pick up a station on almost every frequency, to some degree anyway. I like listening to this stuff. And when you tune it in, they're in the middle of talking about something. Often you can't understand at all what they're talking about, and you're tuning out. So you're basically hearing a whole bunch of out of context comments being made by people as you tune up and down the band, and it can be hilarious. I get a real kick out of it sometimes. I wonder what in heaven's name are they talking about. So that's that interference. I don't know what it is. Simulator there. Could be a strong FM. That's it. It's not very strong. So what you want to listen for also when you're checking an FM radio like this is something called, I guess you could call it full quieting. That's probably not the proper term for it, but when there's no signal in an FM radio, the amount of signal coming out of the IF is low, and it's low enough that it doesn't get affected by the limiter. The limiter circuit's down the way here. So you have this noisy signal coming along, and it just goes right through the limiter. It doesn't get limited, and the noise comes out the other end, and you hear it in the speaker. When you have a powerful signal come, now it's this big, and it's frequency modulated, right? It comes along, but it's got amplitude noise in it. It's just like an AM station. I mean, it's got the noise. It comes into the limiter here, and when it goes through the limiter, now it comes out limited, and all that nonsense is gone. All the amplitude nonsense is completely gone, but the frequency information is still there. So the next stage is to convert the frequency information back into amplitude modulation, so you can send it out to the speaker. Speaker needs amplitude variations, frequency variations don't. Well, I won't talk about that anymore, but anyway. So what can happen is when you tune between stations, and here's the limiter again, and you're hearing the hiss, because it can go through, and then when you hit a station, whoosh, it comes out big, and then the result is the signal coming out is just got no amplitude information in it left anymore. If the signal's weak, it's around the same as the limiter. If you listen carefully, you'll hear some hiss. You'll hear it. It won't have completely been eliminated. And so that you can judge how strong the FM signal is just by listening for this kind of stuff. Not the easiest thing in the world, but let's see if we can spot one that's like this. We're going to find a weak station, weak FM station. You can still hear the hiss because it's not strong enough to get limited by the limiter circuit. So turn it up, Jim. Look for lots of weak stations like there. So here's some noise. It's hard because the program material is there. I still hear it. I'm not sure what that is. So this is that religious station. Hear the noise? Sound? So if the signal's not strong enough to utilize the limiter effect, then it sounds like an AM station with noise in it, lightning crashes, the whole shot will be in there. But everything's been designed, and you should be listening to radio signals that are strong enough to become limited and therefore have all the amplitude modulation chopped off it, if you like, or removed, or however you want to look at it. So that's what's going on with these FM radios. So if it's working really good, you can tune stuff in, and there's no radio hiss at all. And that's happening with this guy. If we come back here, tune in. When it comes to you. Okay, I don't hear any hiss in the background there at all. It's beautiful. Girl, the car. Another thing is, if the signal's weak, of course, the range over which you can tune it successfully gets smaller and smaller. So that's another easy way to tell if you've got a weak station or a strong station. It's kind of obvious, isn't it? Kind of obvious. Okay, there's a little more to do here for alignment. I think I'm going to save it for tomorrow, and we'll see what we get. But I'm pretty happy with its operation right now, even though I'm kind of, I don't know, stumbling my way through the alignment process here. It's coming out okay. So thanks a lot for watching today, and I'll see you tomorrow.